Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 multiple choice questions with only one correct option on work, energy and power. The questions are as follows. Question 1. A body of mass 40 kg moving with velocity 4 meters per second collides with another body of mass 60 kg moving along the same line with velocity 2 meters per second. If the collision is perfectly inelastic, then the loss of kinetic energy of the system is. The options are 48 joules, 64 joules, 92 joules and 120 joules. Question 2. A bomb of mass 1 kg is projected vertically upwards with speed 100 meters per second. After 5 seconds, it explodes into 2 parts of masses in ratio 2:3. After the explosion, the smaller part moves vertically downwards with speed 25 meters per second. Then the speed of the larger part after the explosion is. Take acceleration due to gravity is equal to 10 meters per second square. The options are 48 meters per second, 64 meters per second, 80 meters per second and 100 meters per second. Question 3. A body of mass m1 moving on a smooth horizontal surface directly towards another body of mass m2 at rest and collides elastically with it. After the collision, the two bodies move away in opposite directions with equal speeds. Then the ratio m1 by m2 is. The options are 2/3, 1/2, 1/3 and 1/4. First, let us solve the problem in question 1. It is about perfectly inelastic collision of two bodies. In such collisions, the two bodies stick together and move as one body after the collision. In such collisions, kinetic energy is not conserved, but linear momentum is conserved in any case. For the first body, mass m1 is equal to 40 kg and velocity v1 is equal to 4 meters per second. And for the second body, mass m2 is equal to 60 kg and velocity v2 is equal to 2 meters per second. They are moving along the same line in the same direction. Let the final velocity of the combined mass is equal to v. Applying the principle of conservation of linear momentum, we get m1 plus m2 into v is equal to m1 v1 plus m2 v2. This implies 40 plus 60 into v is equal to 40 into 4 plus 60 into 2. This gives 100v is equal to 160 plus 120 which is equal to 280, or V is equal to 2.8 meters per second. Now, kinetic energy is always lost in such collisions. Now, initial kinetic energy of the system is equal to half m1 v1 square plus half m2 v2 square, which is equal to half into 40 into 16 plus half into 60 into 4, which is equal to 440 joules. And the final kinetic energy of the system is equal to half into m1 plus m2 into v square, which is equal to half into 100 into 2.8 whole square, which is equal to 392 joules. Therefore, loss in kinetic energy is equal to 440 minus 392, which is equal to 48 joules. Therefore, the correct option is A, which is the answer to question 1. Now, let us solve the problem in question 2. It is about a bomb exploding in mid-air into two parts of different masses. Velocity of the smaller part is given in the question. We are required to find the speed of the larger part after the explosion. We will solve it by vector method. For this, we will take the vertically upward direction as the positive y direction. At t is equal to 0, the bomb is projected vertically upwards with speed 100 meters per second. Therefore, we write u is equal to 100 meters per second into j cap. Acceleration due to gravity is g is equal to 10 meters per second square in the downward direction. Therefore, we write a is equal to minus g, which is equal to minus 10 meters per second square into j cap. Therefore, velocity after 5 seconds is given by v is equal to u minus gt, which is equal to 100 minus 10 into 5, which is equal to 50 meters per second into j cap. This is the velocity of the bomb just before explosion. Now, mass of the bomb is equal to 1 kg. Therefore, momentum of the bomb before explosion is Pi is equal to 1 kg into 50 meters per second into j cap, which is equal to 50 kg meter per second into j cap. After the explosion, we have two parts whose masses are in ratio 2:3. Therefore, mass of the smaller part is m1 is equal to 0.4 kg and mass of the larger part is m2 is equal to 0.6 kg. The smaller part moves in the downward direction with velocity 25 meters per second. Therefore, we write v1 is equal to minus 25 meters per second into j cap. Let the final velocity of the larger part is equal to v. Therefore, total momentum just after explosion is equal to minus 0.4 into 25 plus 0.6 into v, which is equal to 0.6 v minus 10 kg meter per second into j cap. Therefore, conservation of momentum gives 0.6 v minus 10 kg meter per second into j cap is equal to 50 kg meter per second into j cap. Therefore, 0.6 V is equal to 60 kg meter per second, or V is equal to 60 divided by 0.6, which is equal to 100 meters per second into j cap. Therefore, the larger part moves upwards with velocity 100 meters per second. Therefore, the correct option is D, which is the answer to question 2. Finally, we will solve the problem in question 3. It is about the elastic collision of two bodies. From the theory of elastic collision, we have the following. When two bodies of masses m1 and m2 moving with velocities u1 and u2 respectively undergo elastic collision and move with velocities v1 and v2 after the collision, then we have v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2, and v2 is equal to m2 minus m1 divided by m1 plus m2 into u2 plus 2m1 divided by m1 plus m2 into u1. When the second body is initially at rest, we have u2 is equal to 0. Therefore, we get v1 is equal to m1 minus m2 divided by m1 plus m2 into u1, and v2 is equal to 2m1 divided by m1 plus m2 into u1. It is given that v1 and v2 are equal and opposite. Therefore, v1 is equal to minus v2. This gives m1 minus m2 divided by m1 plus m2 into u1 is equal to minus 2m1 divided by m1 plus m2 into u1. This implies m1 minus m2 is equal to minus 2m1, or 3m1 is equal to m2, which gives m1 divided by m2 is equal to 1 by 3. Therefore, the correct option is C, which is the answer to question 3. This completes the answer to the questions.